Okay, this is a video on how to simplify radical expressions. So how to simplify radical expressions, lesson 1. This is all we'll get to this year. We won't be able to do it next year. But perfect square reference chart. I went ahead and included this in here, so it's going to be easier for you to see. But square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So continue through. Careful here. I jumped on you, so be careful. It's not just 16. So be careful on those two. I want to point your attention. So pause this right now so you can catch up. But I want to point your attention to here because we have not seen this yet. This is saying the square root of n squared. Well, you're square rooting n squared, so these actually cancel out. So this is just n. Then the square root of n to the 4th power is like saying the square root of n squared times square root of n squared. Well, if those cancel, then you have n times n, which is n squared. So when you're dealing with the variables, it's almost like you're pulling like the even numbers out. Now, I want to warn you, with this lesson, if it gets too confusing with the variables right now, then you may skip the variable part, but use the number part, and I'll explain that when you have a mix. You can try the variables, but don't skip it. You can still do the number part, so I'll show you how to do that. All right, so real quick again, terminology. So remember that this number here is called a root. Now in this case, we're dealing with all square roots. So when we're simplifying the radicals, we're dealing with square roots. But you might see a 3, a 4, things like that. So right now we're only going to deal with square roots. So you're not going to see a number. You shouldn't see a number 2 here. Okay, now this is important. This is the radicand. So in our definition, when I talk about the radicand, that's going to be important. That's the number that we have here. And this is a radical sign. A lot of people call it just the square root sign. Well, with root changes, it's no longer square root. It could be cube root to the 4th root, 5th root. So that's the radical sign. Okay, now in order to simplify a radical expression, a square root radical is simplified when the radicand has no square factors. So a square root radical is simplified when the radicand has no square factors. It means it cannot be broken down anymore. Okay, so we're going to do an example. So here, square root of 33. Well, think back to your factor trees. Hopefully you guys did factor trees. But the only thing that this could be broken down to is like square root of 3 and square root of 11. Now, when you break these down, I am very picky about this. You must have your radical sign. Do not drop your radical sign until you actually simplified it. But square root of 3 and square root of 11, these are irrational numbers. That's not a perfect square. So this is completely simplified. So that is a simplified radicand. Okay, now in this case, when we simplify radical signs, we are not changing it to a decimal form. So don't even have a calculator but with doing these. Okay, so you're doing these all without a calculator. So that's as far as that can go. That is simplified. Now, square root of 18. Is there a perfect square? There's factors that multiply to 18, and are any of them a perfect square? Well, we have 1 and 18, we have 3 and 6, and we have 9 and 2. So what I try to teach you is to go for the largest perfect square if possible. Sometimes we don't see it right away, but square root of 9 and square root of 2 will give you the square root of 18. Do not drop your radical sign and say, oh, I'll add it later. I will count off for this. I am so picky about this because this is where errors happen. Now, square root of 9 can be simplified to the whole number 3. Do not put a radical sign there. Square root of 9 is 3. You're done. Square root of 2, well, you can't simplify that anymore, so that's done. So I like to circle when I'm done with one so I don't drop it. So then your final answer is 3, the square root of 2. Now you don't have to circle this one here if you don't want to. But the radical 18, square root of 18, simplified radical expression would be 3 times the square root of 2. Okay, 75. Is there a perfect square that goes into 75? Hopefully you see that, and that's 25 times 3. So the square root of 25 times the square root of 3 gives you the square root of 75. Now what is the square root of 25? That's 5. So I break that down and I circle it. Square root of 3, you can't break that down anymore. So I circle that. So then over here I have 5 to the square root of 3. That is simplified. Do not change these to decimals. This is the most exact answer that you can get. Square root of 3 is an irrational number, so you'd have to round it because it's going to be a decimal. So do not answer these with decimals. Okay, now, this one. Square root of 180. Okay. Well, I can't think of a square root immediately right off the bat. So instead of just sitting here and guessing and checking, I'm going to go ahead and I know that 3 goes into it. So maybe I can start there. I know 2 goes into it. I know 10 goes into it. So there's a lot of different ways you can approach solving these. It's not always one way. I'm going to go ahead and do square root of 2 and square root of 90. You might have done 3 and 60, or 60 and 3, or 10 and 18. So there's a lot of ways you can break this down. Now square root of 2, I know I can't break that down anymore, so I'm going to circle that. The square root of 90, I can break that down. I can do square root of 9 and square root of 10. Square root of 9 is 3. So I'm done there. Square root of 10, I can still, even though it's not a perfect square, I can still factor out, I can break this down to square root of 2 and square root of 5. Now, these individually can't be broken down, but watch what happens. The 3, oh, and I forgot to tell you, always have the whole number out in front and then the radical sign at the end. So I forgot to tell you that earlier. Now I have 3 times square root of 2 times square root of 2 times the square root of 5. Well, square root of 2 times the square root of 2 is like saying square root of 2 squared. So these actually cancel each other out to where you have now 3 times 2. These together would equal just 2 times the square root of 5. Then these would be 6 square root of 5. What just happened here, if you square it, square root of 2 times square root of 2, well, you're going to get 2 back. So that's 6 to the square root of 5 is this answer here. Okay, so some of these are going to definitely take a little bit longer. I should not just see your work and then your answer. I know you did it on a calculator. Don't pull the, I did it on another piece of paper, staple it to it. I need to see this work. Now, there's a lot of ways you could approach this. But if it's ever the same one, that means that, so what this is telling me, this 6 here, that means 36 could have gone that. Well, I didn't see that right away. And I want you to have to sit and guess and check, so get to work on that. Now, the variables. If the variables throw you off, try it, but don't stop because of the variables. I'm more concerned right now with you learning with the numbers. What this is saying here, remember how when you, to get this exponent of that cube, that could have been x times x times x, because you add the exponents when you multiply, or that could be x squared times x to the first. So you really could break this apart and do square root of x squared times square root of x. Well, square root of x squared, that's just going to be x, and then that's going to be the square root of x. So that's going to be that answer. So when it's odd, you are going to have some left over here. Okay. Now, so here when you have a mix of numerical and variable radicans, you can do square root of 64 times the square root of x to the 4th times the square root of y. I like to separate all of them first, then I can attack each one separately. Well, this is nice. Square root of 64 is 8. Now, the square root of x to the 4th, that's like saying square root of x squared like we did up here with the ends. So this is really saying this is going to be x squared, and then square root of y I can't simplify, so that's going to be, that final answer is going to be 8x squared times the square root of y. Again, if that confuses you, just simplify the number part. We'll deal with the letters. If not this year, you will see it in Algebra 2. So I want you to use the numerical part of the radicand. Okay, so on the back, here are some problems that you're going to work. Sorry about that. And then I want to see your work. And there's enough space on here that you can do it on here. If you don't, you better staple that paper that you said you have it. I know these answer keys are online. I know that. But I want to see your work. If you don't have anything broken down, I think you just copied offline. You didn't learn anything from it. Okay, so square root of 125n. Well, let's break down 125. What's the largest perfect square that you know goes into 125? Hopefully you can see that square root of 25. If not, you know 5 goes into that number. So what I do is I break it down, and I don't forget the n. Now some of these you can go ahead and try. Some of these, if you were leaving off the n, okay for now. Square root of 25 is 5. Now the square root of 5 I can't break down anymore, and the square root of n I can't break down. So this is how it's written. Square root of 5n. So your final answer would be 5 square root of 5n. It's a little high there. That's okay. All right. This one. 216. Well, I know 2 goes into it. Does 3 plus 6, 9. Oh, 9. Okay, so there's a square root of 9 right there if you want. So you can do and then figure out what 216 divided by 9 is. That is 2, that's 18, that's 36, that's 424. So there's a lot of ways you could break down 216. So you can do by 2, you can do by 3, you can do 9. So square root of 9, because that's a perfect square, times square root of 24 times square root of v. Well, that's 3, so I'm done with that. Now 24, the largest perfect square that goes into 24. Well, that's just going to be 4 and 6. Don't forget your v. I bring everything down so I don't forget it. Now, square root of 4 is 2, so I'm done with that. Square root of 6 is going to be square root of 2 and 3, so I can't break that down anymore. So here's our final answer. 3 times 2, so this is going to be 6 square root 6v. So there's other ways you can break that down, but that's how that final answer would be. Okay, 512. I do have to say that took a little bit longer. Also notice once you do it once, it should be the same here. Look at that 216, that's 216. So you just have to mess with the variables. So that is what you're doing on this side. Okay, some of them are nice and easy. Square root of 100. So square root of, 200, be careful, 64. So that's what you're doing on that side.